My name is Charlie Cano. I'm a senior solution architect with F5 Networks. And I've been working with VMware on our partnership for a little over 2 years now. And today we're going to be talking about designing optimal networks for virtual applications and why it makes all the difference. So really focusing around how networking affects applications and how that plays into the virtual infrastructure. And with me is Paul Pindell.
So my name is Paul Pindell. I'm a principal solution engineer with F5. I work on the VMware partnership along with Charlie and a few others. So we're dedicated specifically to working with VMware as a partner. So here we go. We're going to start in. First thing I want to do is let you know that here comes the first audience participation slide. So you guys, these are at the beginning of every slideshow, just so you know, here it comes. Maybe.
Maybe not.
Maybe not. Bob, the button's not working.
Just moves the arrows.
Yeah, there we go.
There we go.
So how many of you are virtualizing at least one mission-critical application?
Great.
Say about 60 to 80%.
Yeah, that's good.
It's pretty good. So on the next slide here, some more stuff from Gartner. Gartner says that in the next 2 years, 1 in 5 IT organizations are going to have no IT assets. They're going to be using cloud, they're going to be using virtualization, and they're not going to have any assets. How many of you agree with that? 2, 3,
Very
4?
few.
Few?
It's a pretty aggressive number there.
It is. It is aggressive. Anybody not have any IT assets yet at this point? No? No one out there? So cloud computing, platform as a service, everything as a service, IT as a service. These are things that are going to enable this drive that Gartner sees. We're going to get close to this implementation tipping point where that's going to be the case. Another slide from Gartner. Gartner seems to think that the complexity of adding yet another process is what is keeping businesses from aggressively implementing virtualization. You're up, Charlie.
So I just want to set the stage a little bit about this conversation. Most of you, I'm sure, are familiar with the OSI model, the different networking stacks and different networking layers. Typically, VMware and vSphere deals with networking for layers 1 through 3. This is our layer 2 networks, single subnet. But the layer 4 through 7 really comes into play when applications are involved. And this 4 through 7 stack, or these 4 layers, are really what application delivery networking is about. And that's what we want to talk about today. So going forward, what is application delivery networking, and why does that matter for virtualization projects? So we're all familiar, servers have become very agile, VMs can be deployed and provisioned very quickly. Storage has become very agile. You've got the vStorage APIs within vSphere. Applications within those can be moved. We're familiar with all this stuff, clients and data centers. But what's missing from all of this picture? And that's really, if you can drive the slides there, it's the network. So network agility is one of the fundamental things and kind of the missing link so far within a vSphere platform and a virtual platform to make applications and to achieve this sort of agility within business process to make these things happen. So questions that we're looking at answering is, how do I improve application performance? How do I administrate automated tasks? We're going to talk a lot about automation. In Steve's presentation this morning, he talked about how automation and business process and workflow and orchestration really helps you achieve these higher order virtualization functions. Extending vMotion beyond a single data center. We're looking at multiple data centers, business continuity, securing virtual desktops over distance, and ultimately just improving user experience across the board. So taking kind of a step back, what's the point of all this? Most people, we talk about networking, you start envisioning something like this picture, where you've got VLANs and subnets and routers and switches and all this good stuff, and it gets really complex really quickly, but that's not really the point of everything. Ultimately, you've got users and you've got applications, and connecting those two is really where application delivery networking comes in. The applications are running in virtual infrastructure within vSphere. That's all the layer 2 through 3 kind of making that fabric work, but connecting those two is application delivery networking. So what do we mean by that? There's a few key features of application delivery networking that we're going to go through and then apply them to virtual infrastructure and why that matters. So the first part of this is really having a full proxy. And this is a control point where users are coming in through this single point of entry, having a full proxy there so that an application delivery controller can do several functions that help improve this experience. It's separating the user connections from the back-end server connections, and then taking policy or the context of who that user is, what device they're coming from, what the network looks like between them and those applications, and helping improve on all those features or all those things. So one key property of an application delivery network is dealing with security. So most people, very simply, security is encrypting the transport, how a user gets there, and the communication channel, making sure that's secure and all the data that's going through that is secure. But it's also security of the user from an authentication standpoint, of the device they're coming from. So are they running, the latest patches? Do they have a personal firewall involved? Is the device they're coming from secure? Do we want to give them access into our infrastructure? So having that authentication and authorization in both points is one of the functions that we talk about. Another one is improving the end user experience. So things like acceleration, specific application acceleration, accelerating just the transport of data, so caching, compression, protocol optimization, things to improve the overall user experience as it deals or it traverses from that user to the application at the endpoint. And then finally, high availability. So this is making sure everything is always available, regardless of disruptions in the network, if a server goes down, if an application instance in a certain VM isn't performing well. Application delivery networking deals with the high availability, monitoring all of that, and making sure that things are dynamically rerouted or readjusted so that you have this high availability. And then a third piece on here is connection multiplexing. So this really has to do with, since you exist as a full proxy, you may have thousands or tens of thousands of users coming in to access an application, and the application delivery controller will terminate those and then open maybe just a handful of connections into the server so that you have a higher performant and more control and multiplex thousands of connections into just a few on the server so they can perform more efficiently.
So Charlie talked about the basic functions of an application delivery controller and what those are. We're going to talk about 4 key benefits that an application delivery network device, an application delivery controller, can bring to a virtualized environment. First is scaling. So we can scale within a data center and scale across data centers using application delivery networking devices. Scaling within a data center is all about increasing the VM density on your ESX hosts. So by doing offload functions and those sorts of things, we can increase the density of the VMs that are running on each individual ESX host. Expanding across data centers, let's say you want to take an application and move it from data center A to data center B. We can do that, move it from cloud A to cloud B, move it back. We can take care of those sorts of things. It's the migrating function that we just talked about. Next is talking about protecting and securing the application as it's in a virtualized environment. And third, we'll talk about managing and automating those functions using APIs and various other workflow technologies. So scaling the application. In scaling, it's all about offloading functions that are traditionally done in a VM, offloading those from the VM, putting them on a piece of hardware, on an application delivery network device, and making sure that the VM serves the application delivery controller takes care of SSL offload and other TCP optimizations, reduces the CPU load on the VM, and thus reduces the CPU load on the ESX host. Allows you to put more hosts per VM. Again, scaling is increased VM density.
Well, one comment, if you want to step back, just this is as a point of example. So what we've done at F5 is tried to quantify some of this. We talk about offload, but what does it really mean? Try to give you some concrete numbers. So one example was running, there's been a lot of reports, VMware's done deployment guides on running Exchange within vSphere and how much better it can run and how much more scaling it can be. So we took that environment, running Exchange 2010, I believe it was, or 2007, because this was about a year ago. Took that environment, following all the Microsoft best practice, the vSphere deployment guides, and drove it to capacity with user load. I think it's about 4,000 mailboxes. So it took that, measured CPU host utilization, and then took an application delivery controller, the F5 device, running the same load, the same environment, the same hardware, and saw a 40% reduction in CPU usage on that host. So that ultimately comes to 60% more capacity on that single host where you can then drive more VMs. So from the sort of first phase of the adoption of virtualization is cost savings and consolidation. That's an immediate turnaround in the consolidation that you can achieve and the cost savings you can do that's 60% more just by offloading functions that are very commoditized. I mean, SSL, caching, compression, almost every application that's connected through the network leverages these types of things or can rely on them. And we can do that more efficiently in custom hardware and let the hosts and the virtual machines actually perform the business function, the application function. Let the server serve and let the network take care of these standardized functions that we can just do more efficiently.
Next, scaling outside the data center, going from one data center to multiple data centers. There are a number of key features the network provides here. So we can provide some global load balancing functions. Global load balancing is a DNS-based mechanism that directs clients. The client comes in, and we can direct that client to the appropriate data center. We can use policy-based methods like geolocation. So we know where the client's coming from. We can look up their IP address, know what region they're coming from, and we can direct them to the correct data center. Time of day, WAN considerations. Your link from data center A is good. The link to data center B is not so good. There's a lot of latency on it. We'll put more users on data center A instead of data center B. This policy-driven intelligence, it brings about key business drivers and key business objectives such as consolidation, business continuity, disaster recovery, and we'll talk about cloud bursting, one of the things that we've introduced here at VMworld. And we didn't change the slide.
There we go. So, question. We've all pretty much built our vSphere environments. We have our applications running. Ideally, if we've moved along that into a vApp, so you've got the construct, you've got the VMs all involved in a particular application. So the question comes, how do you get your application from development, from staging, QA, into the cloud, whether it's a private cloud or a data center that you may have if you've got multiple data centers, or even a public cloud? So the question is, how do you get and actually deploy an application into this environment? Can I go next?
Mm-hmm.
Yep, you can go. So one of the reasons is, why are we doing this? Why are you deploying to, say, a cloud provider or a private cloud, which may be another data center? And there's a lot of drivers for this type of operation. What we've seen in a number of our customers is banks, or the financial institutions, which are going through acquisitions left and right. I mean, there's consolidation across businesses, even within sort of the educational verticals. There's a lot of things happening, and when you acquire a new company or you're just trying to cut costs, consolidating and moving things and consolidating into a single data center is one reason you would want to move applications from one location to another. The opposite could be true, doing capacity expansion. You've filled up the resources in a single data center, and you're starting to look at, say, business continuity or disaster recovery by adding a second location somewhere else geographically located, and just want to increase capacity. So now you've got to deploy your applications in one and expand into the other. The mergers and acquisitions I kind of mentioned, and then also just infrastructure refreshes. What we've seen is a lot of companies now are looking at leveraging virtualization to do a refresh in their environment, move up to the Nehalem processor structures, upgrade into vSphere, and not necessarily take down what they existing have, but just add on to that. So these are all kind of drivers for moving applications and having to deal with deploying them across distance. So then the question is, how do you do that? This is a conversation which surprisingly is left out of a lot of architectural decisions, and when people have, a lot of the customers and partners that I've talked to, they don't often think about how I'm actually going to do this. Moving VMDKs and virtual machines across distance is a significant problem when you come to think of the business implications. There's bandwidth, there's latency, there's cost associated with deploying these applications. So there's a couple of different ways you can do vApp or application deployment across distance. We think of cold migration and live migration. So cold migration is, you're not running the application at the time. It's not serving users, but you still need to sort of push it out. Live migration means you've got your application running. It's serving customers. Clients are using this thing, but you still want to move it as that's happening. Kind of just differences and considerations to have between these two. In a live migration scenario, obviously one of the benefits is there's no downtime. Clients are using it, they want to continue using it, and you don't want to have any disruption to that user activity, but still relocate this application. As part of that, during this migration, and when you're moving, you need to think about persistence and sort of the stickiness between that user and that application. So if you're moving it from data center 1 to data center 2, how does the network across distance, how is it going to manage and maintain that user connection to that app, even if it's moving from New York to San Francisco, and maintaining that persistence? Wait, go back.
You want to go back, Sal?
Yep. You do still also have to worry about compatibility with the layer 2 fabric. So doing a live migration or a vMotion between two data centers, there is some consistency that needs to exist at layer 2 for that virtual machine. When you vMotion it over and it comes back online, that layer 2 fabric needs to have some consistency in certain areas. And one of the misconceptions that we've seen and we work with a lot of our customers about is how much consistency needs to be there. Does it really have to be the same L2? Does it have to be the same VLAN? And in a lot of cases, they're sort of surprised that it does not have to be the same VLAN. You can move and do a vMotion from one data center to another and have that arrive in a different VLAN. The third part here is just the dynamic and global traffic management. If you're moving from data center 1 to data center 2, existing connections need to be maintained open and have that work. But new users, you want to have them go straight to the new data center. So there's a best path or direct path to the new location, all sort of transparent. And then also deal with latency and bandwidth. I mean, moving a VMDK or a virtual machine from one site to another, you're talking about gigs and gigs of traffic that you're going to be pushing across the wire, and that's a huge cost association depending on how many virtual machines you're moving. If that vApp is a web server, an app server, a database, or a set of those, migrating all of that, there's a lot of bandwidth and a lot of network considerations you need to have. And then storage is really the final piece. So thinking about an application, in virtual infrastructure in vSphere, you've got your hosts, and then they've got shared storage. So your application is constantly talking to that storage component. If you vMotion a virtual machine from here all the way somewhere else geographically located, it still has to talk to that storage. So thinking about keeping storage very close to the VM, you need to move the storage as well for that virtual machine. So that's all on the live migration side. Cold migration means the app isn't running. So there's no active users. There's a little, it's a little simpler in many cases. So just having scheduled downtime, making sure that that's, from a business standpoint, appropriate, and dealing with graceful shutdown of that VM for that downtime. So oftentimes, we can bring VMs online, we can shut them down very quickly, but you want to do it in such a way that you're not affecting any users which are using that application or using that VM. So rather than just shutting it down, first you kind of want to say, well, let's do this gracefully. Let's stop letting new users come in. Let the guys that are using it finish their sessions. When everybody's off that VM, then we can shut it down, and then we're ready for the migration. However, the same is still true if you shut down a VM, you relocate it. When it comes back online, you still have those L2 considerations and the what port groups and things that VM is going to be connected to need to be the same, or you've got to think about reconfiguring and doing some, what's the term I'm looking for? The guest customizations. So you've got to retune that guest and retune your VM so that it points to the necessary network connectivity in the new location. So just considerations to have between these two, and when you think about it, how does the network play into all of this? Because it's a really key component. So I want to talk a little more just on the live app migration. Why would you do a live app migration in the first place? So if you've got disaster avoidance is kind of a new term that's come up quite a bit, and our customers, a lot of them have approached us for this reason of, hey, I either know I have scheduled downtime, or I know that there's a potential disaster coming, a hurricane's on the horizon. Just as a preemptive measure, they want to move it, but they don't have the ability to schedule downtime. So that would be one use case of doing a live migration somewhere else. Capacity expansion would be another. You don't want to take anything offline, but you need to move it where you have more resources. Maybe it's a public cloud, and maintain and continue serving users for that, and that would be another case. So the considerations here are just, how do you deal with latency and bandwidth? Am I going to be able to do this? Do I have enough bandwidth for it? Is it going to survive or succeed a vMotion? I mean, typically we think of vMotion as something that's got to happen within a data center or within a very sort of metro area distance. Latency of 6 milliseconds, and there's a number of things. 400 kilometers is typically what we hear when we think of achieving a successful vMotion. But there are other ways to do it where you can expand that distance over hundreds of miles, over 100 milliseconds or 150 milliseconds, and actually do this coast to coast. But considerations are really the WAN and that bandwidth. So, and then finally, the transparent routing, that user traffic. The client needs to know how to reach the application. If you've got it routed to DNS in California and you move the VM to New York, how does the end user know that it's in New York? And that's really where the global traffic management comes in. Okay, so moving a little now into security. Security is typically transport security. We talk about transport layer security, TLS, but then there's also other options like datagram-based transport layer security. So datagram-based means like UDP, whereas SSL or TLS would be TCP. So can anybody think of why having a TCP-based security layer versus a datagram-based might be important? Anybody using PC over IP today? So PC over IP is based on UDP. And one of the benefits and the reason why PC over IP is so much better in a view environment is that performance over distance. UDP is much faster, and the view environment, just that end user experience, is key. Now, if you want to provide secure connectivity for a remote user into a view environment and leverage PC over IP behind the firewall, the corporate firewall, if you tunnel that in SSL, you've essentially ruined all the performance benefits of PC over IP. So DTLS, or datagram-based transport layer security, is a way to achieve this and have a secure connectivity for your view clients that are going over remote or over distance and still access resources behind the firewall or your view environment behind the firewall without impacting performance. So that's one consideration. Also having authentication and authorization, not just of the user with their credentials and logins. You want that to coexist with your existing security infrastructure. So Active Directory, LDAP, but also two-factor, and having PKI support. We deal with a lot of government institutions, and they have very high requirements and existing infrastructure that's got to be considered and work with any sort of access that you provide to your application. So View is one, but really just anything that needs two-factor, smart cards, things like that. Having the network and your security layer support all of those things are considerations to make. The end user experience from a sort of security standpoint and having single sign-on. View is another great example. If you're an end user, you're at home, You open up your laptop, you log into, say, Windows, then you log into View. So there's 2 logins. Then you get to View. Actually, first you do your laptop, then you do the VPN. So you've got to log into your VPN. Then you got to log into View. So end user experience becomes sort of critical to making those types of deployments successful. Streamlining all of it and having one login that logs you not just to your laptop, but also into your VPN, and then also into View, it just streamlines all of it and makes that a much cleaner experience. So to be able to do that all with one policy and a consistency from the administration side, but also the user side, is really something to consider here. What about the cloud? So, is this the, okay. Cloud computing and leveraging public cloud, one of the biggest questions or concerns is security and maintaining ownership of your user databases, your the authentication, authorization, any of that core stuff from a PCI compliance standpoint or from your own corporate requirements. How do you deal with that when it comes to the cloud or when it comes to multiple data centers? Go ahead and go to the next one. So with application layer or application delivery networking and the ability to have network control of how traffic is routed depending on the context of the user, the device and what they're doing, we can do solutions like federated authentication. So here in this case, a user comes in, it's the first time they're accessing an app. The first step is we need to establish that level of authentication and authorization so the global traffic management can route to your private enterprise or your internal data center. That in turn, will authenticate with your directory services. You establish the credentials, you build that secure authentication tokens, and then from there, then you can start routing traffic to either public or private and leverage the computing resources which are in a public cloud. So you're maintaining the control and the access to any resource, but keeping that all internalized and still leverage computing in the public cloud. And then finally, just on the security point, so it's not just securing users and having transport security, but it's also thinking about securing your business. And that's where business continuity comes in. Disaster recovery. If something happens, ultimately, the business is what it comes down to. So VMware and Site Recovery Manager has gone a long way in helping have these repeatable, testable disaster recovery plans. And so Site Recovery Manager, for those of you that use it or may not, it helps when the first data center fails, you have that big disaster, it will rebuild and sort of restart a data center at another location, understands dependencies. Storage is sort of dealt with, and Site Recovery Manager integrates with many storage vendors. But there's nothing in there today about the network. So if Site 1 goes down, Site 2 is back online, how does the user know how to get there? And that's the network. So having an integration there and understanding that with business continuity and disaster recovery, network has to be or should be an automated part of that as well, so that there is an end-to-end solution and an end-to-end automated, repeatable, testable fashion for a disaster. When it does happen, the network needs to adapt and readjust so that when data center 2 comes online and you're back up, users reach it in a seamless, transparent way.
The last topic, the last key function we're going to talk about is management. And management brings it all together. There are lots of moving parts. There are lots of different silos, lots of different organizations that go into making a provision function happen, adding a VLAN, adding something to a networking pool so it can be load balanced. Those are all lots of many different working parts. One of the things you can do is plan for and leverage the various orchestration and automation tools out there. VMware has VMware Orchestrator that's available out there that you can use. There are many commercial and other homegrown tools. And these tools use business processes and they define workflows, and they allow us to bring about and automate many of those tasks. So for example, by integrating an application delivery network with vCenter, we didn't go to the next slide. So APIs are what make it possible. Sorry, that came up. So integrating the application delivery network into vCenter, using the APIs of both, you can automate provisioning based on traffic demand, based on response time to the application. You can automate it on many different things. So these functions, bringing the automated networking changes into and automating them, reduces the risk of human error, the execution time it takes to do these sorts of tasks, and it allows for the implementation of repeatable, audible workflows that span business IT silos. So you can have multiple silos, workflows put into one, or business processes put into one workflow. You can automate those and make them auditable. As an illustration, so we've got, F5 has a solution where we've worked with VMware and the vSphere APIs and the APIs that we have, and we assume that you've got a web client application, a 3-tier application. You've got web front end, application servers, and storage. Assume that demand goes up, more web clients start coming in. VMware can notice this, can notice that the compute on those VMs has gone up, the compute resources has gone up. vCenter can be notified, it detects that. It can then automate and add virtual machines that can serve that load. But we've added virtual machines, but we haven't been able to get any clients to those virtual machines. What we've done is, using our iControl APIs, we've been able to, from vCenter, talk to the application delivery controller. It adds those new virtual machines to a networking pool, so a load-balanced networking pool, so that traffic from clients can get to those devices. You can do it in reverse. Traffic goes away. We can intelligently and gracefully remove those connections. So the connections, we can wait for users to bleed off. We can stop taking new connections to those VMs that are out there. We can tell the iControl, can tell the application delivery controller, the APIs can tell it, to go ahead and remove those from the networking pool so they're no longer receiving traffic. And then we can tell VMware vSphere APIs to go ahead and remove those, power those VMs down. Yeah?
How is that automated? Is that an orchestrator, or is that events, or how exactly?
How exactly are we doing it? So it is through, we've done it through Orchestrator, we've done it through homegrown scripting tools, we've done it through third-party orchestration engines, we've done it through a vSphere API plugin, so through a vSphere plugin. So we've got those different methods that we've gone about making this happen. F5 has a plugin for vCenter right now. We don't have a plugin for Orchestrator, but we've used Orchestrator as the orchestration engine to do this in the past. So it can be done.
Yeah, one of the key sort of the stepping away from F5, but in general, the big picture here is that there's a lot of, there's a lot going on, and you may not, whatever that trigger is, when, dynamic provisioning really says, I want it to expand and contract when things are needed. And what that trigger is, maybe it's application response time, that could be the appropriate thing. It could be CPU load. Depending on the app, there'll be profiles. The application itself will sort of, what the trigger should be can vary from application to application.
Yeah.
On a CPU-intensive app, it may be CPU capacity or RAM. It may be from a website or from a web application standpoint, it could be the response time that end users are seeing as they're accessing that app. And from an abstract standpoint, the point is there's something, or maybe it's a holistic set of things. It could be CPU in conjunction with response time that is that trigger. That in turn will have a series of actions to take in response to that. And that's where you've got to have the holistic view of storage, of computing, and of network, and something, which could be Orchestrator, it could be BMC or HP. There's a number of tools that could be used to be the business intelligence, but ultimately that tool needs to be able to automate the response to it. In this case, vCenter you leverage the vCenter APIs to do the provisioning of a new VM. It could be adding more storage to the storage APIs. The network, given an API, can also be reconfigured to connect to and essentially open up the channels so that those new computing resources can be leveraged.
Yep. So the key takeaway is that the APIs are key. So having an API in your application delivery networking device is what allows for this automation to take place.
Right.
We'd also automate network changes between data centers. So as we move beyond a single data center, there are main functions that global traffic management can perform. So traffic optimization, best path. So defining what is the best path from the client to the application. Is it data center 1, data center 2? Is it New Zealand? Is it New York? Elastic application deployment. So we talk about cloud bursting here, and we talk about that a little bit later.
Yeah.
But cloud bursting is a new solution that we've come up with. It allows for this very same sort of thing. So provisioning an application that you meet a traffic spikes, you have a trigger. That trigger, we're using the vCloud APIs, and it will provision an application in the cloud. So at a pay-as-you-go cloud. So you don't need to you can provision your internal private infrastructure to the mean, and when you reach a peak, you can use the cloud resources on demand.
Just a quick question. How many of y'all have multiple data centers that you leverage? And how many of those have an application in an active-active deployment across them? And for those that don't, is there any plan to or a desire to sort of leverage both in an active-active?
Yeah.
So that's global traffic management in general is really kind of the key point. And what we've seen as a trend in general, I mean, this is the message of the cloud is you want to use everything as efficiently as possible. You know, rather than having lots of hardware deployed and doing it at the peak provisioning, instead, let's take advantage of everything you have, over-provision, and leverage both sites in an active-active standpoint. But to do that, you need to know when to send traffic where, and have a policy-based decision to favor, say, this data center versus that one, unless it starts running out of capacity and then bleed over to here. And just having the intelligence of funneling traffic to the right locations, depending on the needs of your deployment, is what a global traffic management in general is doing.
Integration examples, we talked about dynamic provisioning. Charlie talked earlier about long-distance vMotion, and we just talked about what we're calling a hybrid cloud application architecture, or cloud bursting. You can see demos of these solutions at the F5 booth later on today if you'd like. Yeah,
and Stephen Herod today, I mean, the hybrid cloud is really what we see as the third stage of virtual adoption or virtualization adoption, which is you're starting with your own infrastructure, which may or may not be fully cloud-based or following a private cloud per se, but you want to start leveraging public cloud for the right types of resources. And having the hybrid is really spanning those two, and that's what's meant by a hybrid cloud architecture.
So APIs are the key here. So making sure that your application delivery networking devices have an API that you can interact with so you can create these workflows and automate these tasks and simplify the management. It will bring about a perfect storm that allows people to provision and automate things more quickly and more aggressively use virtualization. So Gartner talked about earlier slide, complexity is one of the reasons, and operational complexity is the reason that people aren't aggressively virtualizing. Being able to have APIs that you can use to automate your workflows will make that bring that about, make it a perfect storm so people can use that.
So just sort of reviewing, there's a lot of moving parts, but ultimately we really care about users, the user experience, the applications that you're using, and how do you scale an app across multiple data centers, how do you make sure it's performant, and the data accessing between users and apps are secure, are performing well. And vSphere really is the platform, and now cloud with vCloud Director is sort of the interface for self-provisioning, for self-service. That is the platform that all this stuff can run on. Keeping in mind that all of that still needs to connect an end user to that platform. And that's, networking is more than just that L2 fabric. It's really all these other considerations that you need to make, like bandwidth and longer distances, WAN. If you go to the next one, the dynamic virtual infrastructure. Keep going. Are those components? So I think we can skip through here. So ultimately, just things to consider in a network is an API. Any automation needs to happen without user intervention. And that's going to cut down on deployment times. It's going to cut down on human error. When you have these complex operations like a dynamic provisioning, or you've got site recovery manager, disaster recovery, these are things that need to be automated, and the API really lets you do that. And I think there's one more just sort of finally, which is thank you. Any questions? Yep.
Yeah.
So the latency latency issue in particular is through WAN optimization. And very quickly, data deduplication, compression, TCP optimization reduces the amount of time, particularly when you're moving multiple VMs. If you've got several Windows VMs or Linux VMs and you're shuffling them over, most of that is redundant bits. There's a little bit that's going to be different in there, so you can optimize the transfer of that just by doing deduplication. Any what? Proxying? Well, as sort of by definition, it is a proxy between the server connection and the client connection. If you want to come offline, we've got a full demo on there and we can dive into it. But yeah, that's a good point. Mm-hmm. Any other questions? Yeah.
Yes.
Mm-hmm.
Yes. Yep.
Yes. So the fact that there is a full proxy, the public address that an end user connects to can change and will change when you move from one site to the other. The address that the guest has remains consistent and constant. So when it's moving from here to here, we're proxying between end users and the app. So even though the IP addresses are changing, we just sort of remap things, but the VM itself stays consistent. So it doesn't notice, it's buffered from any outside network changes and maintains the same IP address, the same gateway, all of that. Well, it doesn't change. It is the same IP address on both sides. It's almost like there's a lot of network address translation happening. If you've used Lab Manager and vCloud Director does a similar thing, you're sort of fencing in the environment that app sees. But outside that bubble, you can do lots of manipulation.
You mentioned, with respect to moving application from VMs,
Mm-hmm.
Interdata center migrations, where your layer topology changes, where your geography
Right.
changes. And obviously, I imagine F5's reference implementation there's used GTM to make DNS changes.
Right.
Is there kind of a recommended implementation? Sorry. For scenarios where that's not really possible. So an example would be, as a service provider, I may not always have authoritative control over my end user's DNS. Mm-hmm. Let's say my customer is anonymously large bank. Large bank is probably not going to delegate authoritative DNS to me, or to my GTM appliances. Mm-hmm. To do that, is there, with respect to kind of network transport or any kind of BGP tricks that you've seen service providers using to get around that?
So as a service provider, which may be hosting some of these things, you don't have to necessarily be the authoritative DNS there, but you would, say, reference down into their own infrastructure and they could run it. Sure.
Yeah. I could.
But ultimately, at some point, there needs to be a dynamic DNS device that can change.
Okay, so really across the board, the recommendation is you need to be able to adjust DNS based on the status of your clusters in one or more locations.
Right, and ultimately, that's kind of the message of all of it, is traditionally networks have been very statically defined.
Yeah.
And the ability to dynamically change based on policy and context. Where does the app live? Who is the user? In the same way that there's that dynamic nature of the computing resources, what host is it running on? What storage array is it running on? That has to be flexible and dynamic, and that's the shift that's happening in networking.
Cool. Thank you.
Other questions? Anyone else?
Great. Thank you, guys.
Thanks.